All right, hi everyone. Welcome back from morning tea. I hope it was nice. I was too nervous to eat anything. So can I just get a show of hands? How many people here are actually teachers? Oh, fantastic, there's heaps of you. Okay, so hi, I'm Thea. This is my first conference talk. So I apologize in advance for talking too fast and finishing in 15 minutes. I was going to do a live demo of creating a lesson, but when I tried in an earlier test, my computer decided that being both plugged into a projector and still having a functioning mouse was just too much to handle. So static slides it is. Anyway, about me. I'm a recent graduate of computer science and artificial intelligence. I went to university in Scotland at the University of Edinburgh, and I felt really behind when I started because unlike all the kids from the UK, I'd never done programming in school. So when I came back to Australia, even though I have no formal teaching training, I decided to jump headfirst into running after-school clubs to teach kids to code. And these past 2 terms, I've been teaching my Year 8 students Python. The main tool I've been using is the PyCharm Educational Edition by JetBrains. So, what's this talk about? There's been a lot said on the subject of teaching people how to program. There have been some great talks and articles on what language you should use, why it should be Python, the sorts of material you should be teaching, but this is a talk for when you've finished doing that. You've decided you want your kids to know Python, you want them to learn about data types and variables, functions, loops, but I know personally, none of that was the hard bit. There's so much material out there, so many lesson plans and project ideas. What was hard was how should I set up a programming environment for kids? They usually can't access the command prompt. So when I was younger, I wanted to be able to program, but I was too intimidated by what I needed to install, how to set up my computer. Nothing worked for me straight out of the box. I know now we're really lucky to have websites you can learn to code at, but they have their limitations, and at some point you need to install something. So this is about what I installed. The software I use, PyCharm Educational. So this talks about how you can use it to teach, how you can create your own lessons, use other people's lessons, some of the pros and cons to using this particular tool as opposed to others. It's aimed at anyone interested in teaching Python, whether you're an experienced programmer or not. I've tried not to make it too techy. Okay, what is PyCharm? It's an IDE, which is an integrated development environment. Basically software for helping you write software. It's a tool to help you create Python projects that assist you with writing, compiling, and running code. It has syntax and error highlighting, so it shows you where you've made mistakes and how you might fix them. It has code completion tools, kind of like the predictive text on your phone. It has version control integration if you want to get your students using Git, which I recommend. And overall, it's just quite a popular IDE in the Python community. And it also has a Python console which you can use, which is great for getting around those school restrictions on using command prompts. The Educational Edition is all that. It's completely free, it's open source, it's available for Windows, Mac, and Linux, and it has additional tools for educators. Namely, there are 2 new types of projects, one for creating and one for taking fill in the missing code type exercises. So, how to get started with PyCharm Educational. You can get your lovely IT staff to install Python 2.7 or 3.4 and the PyCharm Educational Edition on school computers or student laptops. In fact, I'm pretty sure with the Windows version of PyCharm, it actually installs Python for you. So if it's on kids' own laptops, it's pretty much a one-click install. It's very easy. Second of all, if you will be writing your own lessons, you have to open PyCharm on your computer, go to the settings, plugins, and tick Course Creator for PyCharm Educational. For some reason, that's off by default. And with that, you're actually all ready to go. So there are 2 types of projects you can create with students, educational and pure Python. So let's look at educational first. This is what it looks like from the student's point of view. They go create new project, select educational, choose what version of Python they're going to be using, And then they have the option of selecting what course to take. The courses in the drop-down menu are ones that have been created by other people and uploaded to the official JetBrains Git repository. Currently there's a beginner's course, one on logging, on ciphers, and on unit testing. As you can see, there aren't really too many that are actually published on the official one. There are more floating around the web. But yeah, it's a fairly new piece of software, but JetBrains are trying to encourage people to create courses by running competitions. One recently ended. Alternatively, you can click those 3 little dots next to it and select a course from a file. So if you create a course, you can put it on the student drive and they can access it. All right, so say we've decided to do the course on logging. I'll just kind of take you through the interface. So the top left, we have a list of all the lessons in this particular course and the tasks in each lesson. Below that's a description of the course and a progress bar. One of my main gripes with this software is it's a little squished, but you actually can hide most windows. So on the top right, we have the task text. This gives us information. What do we need to do to complete this particular task, any functions we might need to use. And note that by clicking that little arrow next to task text, it hides it. I took way too long to figure that out and kept complaining when the text was too long and I couldn't see any of the code, and I felt really stupid. But yes, below that is the code that we need to edit. So you see the blue boxes? That tells us which bits we need to change. You can click on any of those blue boxes and click on the light bulb, and it gives you a hint about what you need to do in that particular bit. Okay, so we've finished replacing the highlighted text with our answers, and you click the tick button to run and check our code. And congratulations. You click the arrow to go to the next task, and as you can see, our progress bar has gone up. It's very exciting, and kids go mad for it. I made a course, and I accidentally made an error in one of the testing files, so no one could get it to pass the test, even though they had the answer I was looking for. You would have thought I'd just killed their dog or something. Not that devastating, maybe, but they were really annoyed that they couldn't get a perfect progress bar. It's somehow very motivating. Okay, so everything's going along fine. Then you run it and you've got an error. If you don't get it right, it gives you a hint for what you need to change and highlights the boxes that you've gotten wrong. What I love about this system is that it enables kids to go at their own pace. So one of the issues I found with teaching after school clubs is that every student comes in at a different level. So instead of leaving half the kids bored and the other half lost, they work through what they can, ask for additional help when they need it, and I don't have to check every single one of their answers. It also reveals areas where everyone doesn't quite get it, usually when I haven't explained things very well, and then I can go over it with the whole class, maybe write an extra lesson on it next week. So now we get to the exciting bit, which is making your own lessons. I realize a lot of teachers probably won't have time to do this. It takes me the better part of a weekend, but it's not such a bad thing to do it anyway. Once you have made a few courses, it gets easier and then you can reuse them. And I highly recommend it. I have so much fun writing terrible jokes for the kids to not get in my courses. So yes, you give it a name, a description, and you're set. So here is one I made earlier, a lesson we did on the string data type. So projects, as we saw in the student setting, are divided into lessons and tasks. So in this particular one, I have 4 lessons, one on creating strings, on finding and changing things in strings, on splitting and stripping, and on testing things about strings. The first lesson has 6 tasks, and each task has an answer file, an HTML file for the text, and a test file. So here, I hate to shout, but I must stress now, if you are writing lessons, plan them out before you make them. PyCharm Educational currently does not support refactoring of files. You can't change the order lessons are in without manually going into each file and copying and pasting it into another one. And try not to delete lessons, it screws things up. It's a massive pain, and it's one I really hope that they're going to fix in the next version. Well, that's what they've promised anyway. And you might think you'll be tricky and just go into your file system and swap them over. No, doesn't like it. I don't know why, but there you go. Plan your lessons. Anyway, so we've got the answer file. This is where you write the code that the students will see, but you write in the answers too. You highlight anything you want the students to change and add a placeholder. And add the placeholder text, so the students will just see you're a dingbat, and if they click on the hint, it will tell them that strings need quotation marks around them, because I found that's the most common error. So make sure you've finished, you write your whole file and then add the placeholders. Otherwise, this happens. You can't go to the next line because you're just stuck in a placeholder forever. It's really annoying. Okay, so in the task.html file, you write what you want the kids to read. Hyperlinks, bold, and breaks are the only HTML that really works, but I think that's plenty. Also, I'm not sure if other teachers find this, but kids often don't even really read what you've written anyway. They'll skim over it, they'll skip to the last line where it's telling them what to do, then get really frustrated when they don't know how to do it, even though it was written in the second sentence. But I digress. The tests file. See on the left, there, kind of bad resolution, but there's a file called test helper. That contains all the different methods you can use for testing. You can check what they wrote in the placeholder and also what the output was when they ran their code. Just note, it converts everything to strings, which is kind of annoying. But it also runs the bunch of common tests, which are things like, did they edit the file? Is the file empty? Did they just delete all the placeholders? And when you're done, you right-click on the project and generate a course archive. This is the file that you send to students. So it's just one file you send them to them, and they open it as an educational project. All right, so what sort of lessons does this actually work for? Unfortunately, nothing where you want to use external file input or keep code students have written from one exercise to the next. Reading and writing to files is currently not supported in the educational projects. The best sort of exercises are ones that have a set answer, either very specific syntax they have to use or a very specific output. Then for bigger, more complicated projects, I just use an ordinary project in PyCharm and we work through it as a class. So here are some more examples of lessons I've made. So this particular one had 2 challenges. Learn how to make a computer print the lyrics to 99 bottles and make a higher or lower guessing game. So this is what it looks like in the course creator. This is a task where you have very specific syntax. So I want them to print a list of numbers from 1 to 20 and I want them to use the range function. I want students to write, exactly what I've written. And this is what it looks like from the student point of view. So all the stuff I wrote and then kind of empty code to fill in down the bottom. This is another type of task I like where you have multiple possible answers. So instead I'm testing their output. So all should be true. And that's what it looks like from the student's point of view. But when you're finished with the constraints of lessons, say you want to be able to keep code they've written without it being all in one big file, it's time to move to a pure Python project. So that's what those look like. You've got your project structure on the left, code editor on the right, the little green arrow button to run. You've got a Python console down the bottom you can use. So here we were creating a virtual pet, learning about classes and objects. Pretty cool. So this is one of the features. When you type in a variable and a full stop, you then get a list of all the methods